Good morning, students. So today we're gonna start our next topic of chapter 1, that is matter in our surroundings. In the previous lecture we have learned about the effects of change of temperature. That is, by changing in temperature we can change the states of matter. That is, by decreasing the or increasing the temperature we can change the states. That is, solid, if we will increase the temperature, will convert into liquid, and further, if we will increase the temperature, the liquids will convert into gases, and if we will decrease the temperature, the gases will condense and turns into liquid, and after more decreasing the temperature, the liquid will turn out to solid by freezing. So all these change of states of matter, either by increasing or decreasing the temperature, causes the change. That is, either the solid will melt, or it will vaporize, or it will condense, or it will freeze into different states of matter. So today we're gonna start our next topic, that is how the effect causes by changing in pressure. Effect is caused in the state of matter, obviously. So today, if we will change the pressure, we can make gases as in a liquid state, or even we can convert gases into solid state. So how does this happen? Okay, now the physical state of matter can also be changed by changing the pressure. So gases can be liquefied by applying pressure. If we will apply pressure to the gases in a low temperature, very low temperature, that is how we can change gases into liquid. Because if you remember that solids have different arrangement of particles, liquids have different arrangements of particles, and so as gases have different arrangements of particles. Because the particles are differently arranged, if we will make the change in the arrangement of the particles, so gases can behave as liquids, or further we can change the arrangement of the particles, the liquids can behave as gases. So by applying very high pressure at a very low temperature, we can convert these gases into liquids. So when a high pressure is applied to a gas, it gets compressed. So how is the compression works? I can show you with a simple diagram. That is, just imagine that you have taken a cylinder. Okay, so that's how the industries work. You would have seen LPG gas cylinder. In that cylinder you would have when the cylinder is filled, if you try to shake the cylinder, it will just feel like there's some liquid inside the cylinder. That is the LPG gas, which we call as a liquid petroleum gas, which is a gas. If you'll turn the regulator on, it will come out as a form of gas, but inside the cylinder it is in the liquid state. That means the gases are compressed so much that they behave as liquid, and as soon as they come out to the atmosphere, they comes to their original position. That is why we are asked to store the cylinders at a low temperature. Now, if we will take a cylinder, simple cylinder, here is a piston. Piston is just a pump-like structure by which we can push it in a downward motion. So these are the description of the how the gases particles are arranged. So they are, because it is a gas, so they are very widely arranged. So now this, if we will push the piston inside, as we know that gases have a very high compressibility, we can compress them. So if we will push the piston and we will compress it, we will push the piston so that we are compressing the gas. Okay, so we are compressing the gas, but also we are cooling the temperature. Again, more compression, and the gases are particles arrangement, they are coming closer because we are compressing it. So the particles are coming closer, and we are cooling the temperature also. Again we are compressing it. So what we'll see, that the particles of gases will be so close to each other that they will start behaving as liquid, because they will show the arrangement of liquid, because liquids are slightly closely arranged as compared to the gases. So if we will again compress, so they will turn as liquids. So the particles get so close that they liquefy. So this is how we can compress the gases. Also it happens sometimes that there is a chamber in which the gases which is compressed is coiled. Then we have to apply very freezing water into that, and that is how the gases are liquefied. So when high pressure is applied to any gases, it gets compressed into a small volume. That means the volume becomes small. Here the volume was high and here the volume become very, very small. Okay, so the volume decreases. And when we also lower the temperature, because we have to lower the temperature because we are applying the high pressure and then we are lowering the temperature by cooling and by compressing it, so we can see that gases can be liquefied by compression and cooling. So the conversion of solid carbon dioxide into carbon dioxide gas is change of state in which is caused by the decrease in pressure. So now by this process, when we compress the gas, example, we can compress many gases such as CO2. In the case of CO2, what happens, we have to compress it, but here it has turned, this gas is turned into liquid state, but there are some gases which do not convert into liquid state, they directly come into the solid state. So from this stage to this stage, and it will just solidify, it will just become solid or ice. So the compressed or the liquefied CO2, we can't say liquefied because it becomes solid. Okay, so from the gaseous state it will directly come to the solid state. So we also call it as dry ice, because ice are when when they are released to the temperature, when temperature is increased, the solids turn into liquid. But here in the case of CO2 dry ice, the dry ice will directly convert into its gaseous state. But there are some gases such as ammonia, it can be liquefied by applying high pressure and low temperature. So if there's a question that what is dry ice, so the answer will be simple: CO2 or carbon dioxide. That is a white color solid. It is a dry ice, and it is also used in deep freezer because it also helps to keep ice creams and all the things cold. And whenever it will come into the high or normal temperature of the room, it will directly convert from the dry ice to the gaseous state. Okay, now the conversion of solid carbon dioxide into the first solid, the CO2 will be in gaseous, and if we will reduce the temperature and compress it at a very low temperature, it will form as a dry ice. And if that dry ice is again changes, it is allowed in a high temperature, it will again decreases and it will again convert into the CO2 gas. Okay, so now next is evaporations. So now by this we know that there is a difference by the changing in pressure. Now coming to the next topic, that is evaporation. Evaporation is a simple process which I think you all know. It is about the when a liquid. Now, if you remember vaporization, vaporization is a process in which the liquid starts boiling. That means boiling starts at 100 degrees C. So the water get vaporized into gases or into vapors, but not in the case of evaporation. In the case of evaporation, the liquids converts into vapors even below its boiling point. So the water does not boil, but it evaporates. You would have seen the whenever you spill a water in your room and you forget to clean that water up, after an hour or 2 hours, if there are a few drops of water, it will get dried up, the water goes away. That means it evaporates. And this evaporation happens in summers more, but less in the winters, and very less in the case of rainy season. So because evaporation is dependent on some factors that we'll be learning. So first, the evaporation is just a process of converting the liquids into vapors even below its boiling point. Okay, now whatever be the temperature at which evaporation takes place, the latent heat, if you remember the latent heat, the minimum amount of heat required to convert 1 kg of liquid into vapors, it's called as latent heat of vaporization. So this vaporization's latent heat must be supplied whenever liquid changes into vapors. So that is a heat which is hidden heat which we apply or it uses from the atmosphere. That heat does not raises the temperature, but it is working in there, which helps to convert one state of matter into the other state, be it is a latent diffusion or vaporization. But here in the case of evaporation, this latent heat of vaporization helps to evaporate the water from the surface. Now, the factors affecting evaporations. There are 4 factors which affect the evaporation. They are temperature, surface area of liquid, humidity of air, and the wind speed. So now first, temperature. You would have seen that in summers there is a more evaporation. Example, if you try to wash your clothes or anything and you just spread it in the sunny days, you notice that your clothes get dried up in just 1 hour or two. But same in the case of winters, if you try to keep your clothes in the sunshine or in anything, they don't get dried up. It takes a lot of time, even a day or two, because the rate of evaporation decreases in winters. That means temperature somehow plays an important role in the evaporation. So the more the temperature will be, the more will be the evaporation. So the rate of evaporation increases on increasing the temperature of the liquid. So when the temperature of the surroundings is high, the evaporation will also be high. Okay, and the second is surface area of the liquid. Okay, for example, if you take some 2 ml or 5 ml of water on a plate, and then same amount of water in a glass, and just keep it in the corner of the room, what you'll notice, the water which is kept in the plate will evaporate very soon, but the water which is in the tumbler will not evaporate so quickly. That means surface area somehow plays an important role in the evaporation. The more the surface area, the more will be the evaporation. Also, simple example, whenever you see your mother drying up clothes, she always spread the clothes properly in that anything on the rope. But have you ever seen her keeping the clothes by making a bunch? No. If you'll make the bunch of the clothes, they will never dry up, or they will take more time to dry up. But if you spread the clothes properly, it will evaporate very early. So if you increase the surface area of any liquid, the evaporation will be more. So the more the surface area, the more will be the evaporation. The rate of evaporation increases on increasing the surface area of liquid. Okay, the third is humidity of air. All these four points are important, so please learn this. Humidity of air. Now, humidity of air is the degree of dampness. That means how much is the atmosphere damp. That means you all know that atmosphere have some water vapors, but in the winter season there are a lot more water vapors because the air is damp and heavy. But in the summers there are lesser water vapors in the atmosphere because it is heated up and the water vapors get dried up. So the more the vapors, the less the evaporation. That means the humidity decreases the evaporation because of the humidity. Now, why the humidity decreases the evaporation? There is a reason that in the rainy season, evaporation needs a latent heat of vaporization. Now, how is this given? Some gas particles already have a high kinetic energy. Now, this energy helps the particles of the liquid to move from one place to the another freely. So, when these particles move, they take the energy from the environment or from the surrounding into which they are. So by taking the energy of the surroundings, they get the charge. But if there will be already particles of water in the atmosphere, they will hinder the space, and hence they will not allow the particles to move more freely. And when they will not be moving freely, they won't be behave as gases, so they will be liquid. That is why if there is more humidity, there is a less evaporation. Rest all the other factors, apart from this humidity, all the three factors, when they increases, the evaporation increases. But when the humidity increases, the evaporation decreases. Or if the humidity decreases, the evaporation increases. Okay, so only humidity is the opposite, or we can say that inversely proportional, but the other things are equally. Okay, now wind speed. The more the wind speed, the more the evaporation. When there is a cool breeze, or whenever you keep your clothes or anything under the fan, so they dry up quickly. So if there is a high wind speed, there is more evaporation. Okay, so evaporation, the rate of evaporation, factors that affect the rate of evaporation are four factors. That is wind speed, surface area of the liquid, temperature, and humidity. Three factors, that is temperature, wind speed, and the surface area. If they increase it, there will be increase in the rate of evaporation. But humidity, if it increases, the rate of evaporation decreases. Okay, now evaporation causes cooling. That means, example, whenever you run in a ground or you play in the ground, okay, after when you play, your body sweats, okay. Now after you have finished your game and all, when you take rest, your body is wet, and you are sitting in a shed, and suddenly there a cool breeze comes, or you sit under the fan, you slightly feel cold. Have you experienced that? Okay, now when you feel cold, that means your body is wet, and the air which is flowing, the air is evaporating that water or the moisture or the sweat from your body. So the sweat from your body evaporates by taking the heat from your body as the latent heat of vaporization. Since the heat is taken out from your body, which helps to convert that vapors or sweat of your body into gases. Okay, the sweat, that is liquid of your body, into gases, the heat is taken out of your body, so your body temperature will be lesser. So if your body temperature will be decreased little bit, you will be feeling cold. That is why evaporation causes cooling. So that is, when a liquid evaporates, it draws or takes the heat or the latent heat of vaporization from anything, anything, either from the environment or to any body or any surface into which it touches. So because it is taking the heat from that thing, so obviously it will decrease the temperature. Example I've written here is, during hot summer days, water is usually kept in a earthen pot to keep it cool. Because we keep the water into earthen pot so that it will be cool in the summer days. Because earthen pot have large pores, you would have seen that it has a porous surface, so water comes out from that pores. So when the extremely small pores or the water comes out, so because the atmosphere outside is very hot, the pores of water gets vaporized, taking the heat from the pot. Okay, so the heat is taken from the pot or from the water. Since the heat is taken of the water or the pot, the temperature will be decreased, and when the temperature will be decreased, the water will be cold. That is why evaporation causes cooling. There are many examples. If you keep any acetone or any alcohol in your hand, so tendency of alcohol is to vaporize quickly. So it vaporizes because it uses the heat from your hand. So because it is taking heat from your hand, so your hand will be feels cold. Okay, so there are many examples. You can also consult your book, into which you can learn about the evaporation. Now the topic was, this water evaporates and takes a latent heat required for vaporization from the earthen pot and the remaining water. So the water loses its heat and gets cooled. So once again, I would like to tell you that during these hot summer days, when we keep water in an earthen pot, the water comes out from the pores of the earthen pot. Since the atmosphere is hot, so the water get vaporizes by taking the heat from the earthen pot, due to why the temperature of the water is decreased and the water becomes cool. So this is what the evaporation causes cooling. Now the last topic is that water vapors are present in the air. We all have heard about that atmosphere. They have the water vapors in it. So how we can conclude it? So we can conclude by a simple experiment, which I will be telling you only. If you would have seen in summers also, if you put very icy cold water in a glass tumbler or in any steel tumbler, any tumbler, after some times you feel some droplets of water in the sides of the wall of the tumbler outside. Have you experienced that? Okay, why does it happens? That happens because the atmosphere around that, or the environment around that, like it's a glass, okay, and you keep some chilly water in this or ice cold water in this, you would have seen some vapors in the side of the glasses, because the atmosphere near the glass is high, or it has some waters in it, so vapors or gases in it. So when they will come in the contact of very cold container or very cold thing, the vapors which are present in the atmosphere will get condensed. Okay, so when they will condense, they will convert into droplets of water, and they will just form the droplets of water here in the sides of the glasses, because this is the body which is very very cold. So all the vapors which are in contact with this container will get condensed, and we can see in the form of water droplets. So this is how we can conclude that the atmosphere in the atmosphere or in the air, water vapors are present. So this was the last topic of your chapter. I hope you understood the chapter very well. I've given you few questions, so everybody please do that question, because they are very necessary to do even in the all subjects, so that teachers can mark your present. That is very very important for you people. So please do the question so that I can understand what you're getting. And if you are having any problem, you can write that question in the description. When you submit your homework, I will check it and I will tell you the solutions also. Till then, study hard and be safe. Thank you.